In this video, we are going to be learning about real numbers. So, in order to learn real numbers, we must see its subcategories or branches, like what it is made of. So, I'm going to start off with natural or counting numbers. So, natural numbers or counting numbers are those numbers that are like they have only the concept of all the numbers except for 0. So they have no such concept of 0 as a number. So all the numbers that start from 1, like 1, 2, 3, 4, and up to so on up to infinity, as numbers are infinite. So you see in the beginning there is no 0, which means there is no 0 as a number. Well, now there is a 0 as a digit. We must clear that. So like there are two numbers, let's say one is 10 and let's say 100, or any other number that has a 0. And then here we have just a 0. Now there is a difference between these three numbers. Here this 0 is as a number. Here this 0 is as a digit. And just like that in here as well. These two zeros are as digits. So in natural or counting numbers, there can be zeros as digits, but there cannot be a 0 as a number. Alright, well that's pretty easy. The next one we're going to talk about is integers. So integers are all positive and negative numbers. So for natural numbers, they are all positive numbers, and there is nothing like decimal numbers or negative numbers. No, all positive numbers. Integers, there are positive numbers, there are negative numbers, and there is also a 0 in it. So we have seen the positive numbers already. Now we're going to see negative numbers and a 0. So I'm just gonna draw a number line to give you a brief idea of what integers are. So in the center, in the middle, we have a 0, and then to the right side we have positive numbers. I'm not writing positive sign with them, just for you to learn that whenever there is no sign with the number, it is considered as positive. So to the left side of the 0, we have negative numbers. Now you must remember that all the numbers to the left side of the 0, they are less than 0, and all the numbers that are to the right side of the 0, they are bigger than 0. So negative 1 is less than 0, then negative 2 is less than 1, negative 1, and then negative 3 is less than negative 2, and so on. So whether a number is positive, negative, or whether it's a 0, they're all integers. Now 0 is in the center, which also means that 0 is neither positive nor negative. Right, moving on. Next one is rational numbers. Now I'm going to define rational numbers in two ways. So the first one is like pretty simple and not that much confusing for fresh learners or for beginners, or for those people who are like kind of struggling with math. So rational numbers, so we can just simply say that all positive numbers. You have seen positive numbers in natural numbers. All negative numbers, so you have seen negative numbers in integers as well. And then we can say that all fractions. Fraction can be positive or negative. And obviously a 0. So they are all called rational numbers. If a number is positive, it's rational. If a number is negative, it's rational. If a number is 0, it's rational. If a number is presented as a fraction, there is a fraction, whether it's positive or negative, it's rational. So you might have noticed that I'm going in a sequence. I've started with the smallest category and then I'm gradually increasing it, making it bigger. So we started with the natural numbers, then integers. So integers has the concept of natural numbers or positive numbers. Then we are now on to rational numbers. So rational numbers has the integers in it, but some new numbers as well, which are fractions. So let me just write some examples. Now, fractions also mean decimal numbers. I do not consider fractions and decimals separate things. So I haven't written decimal numbers in here, but decimals are also rational. Why? Because you can see my other video on my channel as well about decimal numbers. It'll give you better idea, but right now, in short, I'm gonna just explain it like decimal numbers are another way of writing fractions. So like 1/2 can be written as 0.5. So 0.5 is just another way of saying 1/2 or another way of saying a half. Okay, now let's make it a bit more complicated. So let's say there is a number that is 1/√2, and as we have said already that all the fractions are rational numbers. So whether this fraction is a rational number, there is a square root in it, and this definition doesn't say anything about square roots. Well, for these kind of numbers we need to modify the definition. So now I'm going to give you the usual definition of rational numbers, which says that rational numbers are always in p by q form, where p and q are integers and q must not equal to 0. Well, why is q not equal to 0? That's a topic, that's something for another time. But then it leads to infinity for now. So it must be in p by q form. P and q are both integers. Alright, so 1 is integer and square root 2 is not an integer. There is a square root on it, and integers don't have a square root on them. But still, I like just to make it a bit more clear, let's say that rational numbers are terminating decimals. Now, what does terminating decimals mean? Well, just like I gave you the example above there, that 1/2 equals 0.5. So you see 0.5, it's fixed, it's exact. The word terminate means end, to end. So when you divide 1 by 2, you get a fixed and exact answer of 0.5. So it's ended there, the decimal portion. So if a number is a terminating decimal, if a fraction is terminating decimal, because we have only doubts about all fractions, there are certain fractions that we doubt about whether they are rational or not. So if a fraction is a terminating decimal, then it's rational. If it's non-terminating, then what? Well, if it's non-terminating, then let's say there is a fraction like 2 by 3. So when you divide 2 by 3, it gives you 0.666666666, recurring decimal. We call it recurring decimal, and we just write it as 0.6 and then a bold dot or a bar above the 6, which represents that 6 is recurring. So you see, non-terminating means that after the decimal point, the digits are kind of infinite. They're infinite, they're limitless. So it's non-terminating. So if a number is non-terminating, then it must have the repeating decimal or recurring decimal property. Repeating or recurring. Decimal. So you see, after the decimal point, 6 is repeating. So now that's repeating decimal or recurring decimal. Not just 6. It cannot be just a single digit. There could be like lots of multiple digits, I mean. So let's say there is a number as 0.147, 147, 147, and so on. So you see here, there is a group of digits repeating. So this is also a rational number, as there is repetition. It's non-terminating, but it's repeating decimal, so it's rational. Alright, moving on. The last one is irrational number. So irrational numbers are really easy when you know the concept of rational numbers as in P by Q form. So in short, I'm just gonna write down that irrational numbers, they are non-terminating decimals, and they are non-repeating decimals. But there is a confusion, like whether we are gonna divide them and check whether it's repeating, non-repeating. Now, let me just give you a trick. So if there is no square root involved, then it's right away rational. There is no doubt. Whenever there is a square root involved, then you must check that if there is a perfect square inside the square root, like 4 is a perfect square, and by perfect square I mean like there is a number, when you square it, you get 4, which is 2. Square the 2, you get 4, 9. So you square the 3 and you get 9. So 9 is a perfect square. Just like that, 16. You square 4 and you get 16. So when you get a perfect square inside the square root, then it's not irrational, because under the root 4 is equal to 2, and 2 is a whole number or an integer or a rational number. So the thing is that whenever you get non-perfect square number inside the square root, like let's say 3, now 3 is irrational number, because when you find square root of 3, you're gonna get non-terminating decimal and non-repeating decimal. You can try it using your own calculator. So that's a trick. Just by looking at it, you can tell whether a number is irrational or rational. Just like that, 7 is not a perfect square, 8 is not a perfect square, 10 is not a perfect square. So all these non-perfect square numbers inside the root, they are called, these numbers are irrational numbers. Also one thing, the number inside the root is called radicand. Radicand. And this symbol, root, is also called radical. That's its actual name, radical sign, and the number is called radicand. Okay, now let's just put it all together for real numbers. So we can say that the union or the combination of rational and irrational numbers are real numbers. So that means that each and every kind of number is called real number. If I am going to write them hierarchically, then it's gonna look like this. Look, natural numbers, and then integers, and then rational, and then irrational, and then real at the end. So now let's put them in boxes. Wow. So the integers category is bigger. It has enclosed the natural numbers with it inside. And then irrational numbers, it's bigger than integers. So you see integers and natural are both inside the rational box. But thing is different for irrational. So you see irrational is just alone there. And then for real, so they're all called real numbers. That'll be all for real numbers. Take care.